There is an important concept in object-oriented programming, and that is polymorphism. Poly means many and morphism means behavior. So polymorphism means many behavior. And in technical term, uh, polymorphic behavior is when an instance of a particular class behaves more than one other instances of classes. Let me put it in a simple way. For example, when you are inside your home, you may be the son and daughter of your parent, and when you are in school, then you become the student of that school. When you ride on a bus, then you become a passenger of that bus. So the same person, the same you, have different role based on the situation. So in Dart or in object-oriented program, an object can behave more than other instances. So in our case, we have a car parent class, which is abstract, and we have two subclasses like electric car and fuel car. And we have two instances of our child classes, and both of the child classes overridden the drive method of the parent class. So if we have a situation like this, that means all of the child classes override a specific method from a parent class, then we can call that method polymorphically. In our current situation, we are calling the drive method with the corresponding instances. For example, we are calling the first drive method by using the electric car reference, and we are calling the second drive method by using the fuel car reference. So these are the corresponding references, and when we call the drive method, then the corresponding drive methods are called. But we can call this drive method polymorphically. How? Let me show you that. For example, in a database, there are all the car informations like electric car, fuel car, and other cars. And you ran a query and you got all the cars information as a list. So let me define a list first. So final car list, and that would be a list, and inside that list I am just putting the electric car and the fuel car instances. Okay, and the type of this car list, if I put our cursor over here, it says at the suggestion, it says the list of car. So let me put the type over here. So list of car. You might be thinking that this is an instance of electric car and this is an instance of fuel car. In open eyes, it may seem that these are two different instances of two different types. But basically, these two instances are of the same type. That means car. And whenever we have an inheritance situation, for example, this electric car extends car and fuel car extends car, and inheritance is basically a relationship. So we can say that electric car is a car and fuel car is a car, but we cannot say that every car is an electric car and every car is a fuel car. And that's why we can actually put a child class reference to a parent type, just like this. Like let me have a car type reference. So car, and I cannot actually instantiate a car type directly by calling the constructor, because car class is now abstract and we cannot create an instance of an abstract class. But what we can do is we can actually put a child class reference into a parent type, so there is no error. And this is because of the is a relationship, because every child class can be represented by its parent, and child class inherits all the public properties and method from the parent, but the parent will not ever know what extra parameters are defined in the corresponding child classes. So the car class will never know how many extra properties or how many extra methods are there in the child classes. So The summary is we can actually put the child class object in a parent type, and that's why the list is actually a car type rather than an electric car or fuel car. And for example, if it was an electric car list, then only the electric car instances will be should be put inside this list. So there is an error because this instance is not a type of electric car. But when it is car, that means the parent type, that means inside this list we can actually put any subclass instances of car class. Okay, so now that we have a list of cars that actually includes a different type of cars, and now we can run a loop, and then we can call these drive methods polymorphically. So let me remove these lines and let me run a loop. So for final car in car list. Look carefully that I have declared a variable of type car, that means the parent type. And now if I call car.drive and if I run this application, the output will be same. But the important thing to notice is I am using the reference of the car type, that means the parent type. And actually at the runtime, the corresponding class drive methods are called. Since it may look like this car is a type of car, so whenever I call the drive method, it should actually call the drive method that is inside this car object. But this drive method is never called. So in this situation, that means when the loop actually run for the first time, so this electric car reference is put in this reference, car reference, and the drive method is called of the electric car class, and the second time FC, that means fuel car class reference, is put inside this car class object, and second time the drive method is called of the fuel class car. So same car reference of same type. At the first iteration, it is behaving like an electric car reference, and at the second iteration, the same car class reference is behaving like a fuel class reference. So this car class its behavior is now polymorphic. You will see many examples and design patterns based on this polymorphism or the parent type. So whenever we design a component or create a component, and when we have multiple types of the same type, or we have subclasses, many subclasses, and we need to call some methods, then we actually call this polymorphically, because it's a design pattern and it requires less modification in later. For example, let me put these lines of code in a separate method. For example, let's define a method called void, and maybe the method name should be check drive mechanism. Check drive mechanism. Okay, and this method takes a car instance instead of the child instance. Okay, and now the method will simply print the car drive method. Maybe I should not wrap it inside a print method, because this drive method doesn't return anything. So okay, so now we can use this method instead of directly calling this drive method over here. We can simply call this check drive mechanism method over here, because we are trying to encapsulate the features, or we are actually dividing our codes into separate modules in this way. So check drive mechanism, and just pass the car instance over here. If I run this application, the result will be the same, but we have defined a component or a separate method that takes a car instance and then calls the drive method. And from now on, if you create another class or subclass of car, for example, let me just copy this whole class body and paste it, and then change the name of the class as for example, gas car, so that the car that runs on gas. Okay, And maybe this could be gas capacity. And the constructor name, let's change the constructor name, and let's uh, provide the appropriate name for the constructor, and then the drive. And from here, just change the fuel to driving a gas car. So I have defined a new type, and let's create a new reference of our gas car object. So gas car, and provide a name, maybe Mercedes. I don't know whether Mercedes runs on gas or not. And this is the gas capacity. And let me put this gas car instance in the car list. And now, if I now run this application, we'll be able to see all the driving, all driving mechanism from all the cars. So if I run this application, you will see that driving an electric car, driving a fuel car, and driving a gas car. So we actually can now add as many subclasses as we want, but to do this we don't need to modify this method. So this method is built in such a way that no matter how many subclasses we create, but this method will be unchanged because we actually use the parent type over here. So this method will receive any subclasses, any subclass of car class. So this is the actual benefit of using parent type. And by using polymorphism, we can actually call a method that is overridden in every child class and call them sequentially by just one single line.